My agent told me it was done. It wasn't. It ran for 40 minutes, burned through tokens, and produced confident garbage. Every output looked polished. Every conclusion sounded reasonable. But when I checked the actual results against reality, it had been solving a completely different problem for the last 30 minutes and I didn't know it. I call that a Ralph Wiggum loop. And if you're building with AI agents right now, it's coming for you too. Today I'm breaking down what loops actually cost, how they fail when nobody's watching, and the honest question that none of these YouTube videos want to ask. Do you even need to use loops? I'm not drawing architecture diagrams on a whiteboard. I run a 24/7 AI agentic team with loop systems in production. I've watched them fail at 3 a.m. and I've audited the security of AI agent pipelines that handle real credentials. I've seen the broken bull after loop ran longer than it should have. Everything I'm about to tell you comes from shipping these systems and living with the consequences.
Hey, I'm Johnny Nell. I spent years building businesses the old hard way, managing teams, scaling operations, and doing everything manually. Today, everything I built, from automations and no-code infrastructures to fully AI SaaS products, has AI helping in one way or another.
Firstly, let me quickly show you this. In South Africa, we call this a braai.
I build with AI tools that, in my opinion, anyone can learn to use. My mission is simple: to help creators, entrepreneurs, and business owners get clarity with AI. Let's build smarter together and enjoy this video.
Here's why that matters right now. Loops are being built as the natural next step for every burger. Heck, even Peter Steinberger mentioned that this is something that all builders should be studying. You see, tutorial makes it look simple. Perceive, reason, act, observe, repeat. But what they don't show you is what happens at scale. The cost isn't just tokens, it's debugging a system that nobody on your team fully understands as of yet. Specifically if you're a non-technical founder. You see, it comes with running permissions nobody's audited, producing outputs nobody's verified. And if you don't know how loops fail, then you don't know they are failing until the bull arrives or something breaks in production. So let's start off with the obvious question. What is an agent loop? A quick foundation here so that we're all on the same page. An agent loop is when AI doesn't just respond once and stop. It keeps working. Perceive the environment, reasons about what to do, take an action, observe the result, and repeat until some condition is met. Instead of you prompting it 10 times, it prompts itself, and that's the pitch. And it works sometimes. If you've worked with a lot of vibe coding tools, you'll probably see a lot of this happening. And Replit does this very well, by the way. But the gap between works on a demo and works in production at 3 a.m. when nobody's watching is everything I'm about to cover live. So let's look at the economics nobody mentions when it comes down to agent loops. So let's talk about the money. According to industry analysis from LeanOps, multi-agent loops consume roughly 15 times more tokens than a standard chat interaction. That's the median. A simple 3-agent loop running for 20 minutes can cost more than an entire day of normal usage. And these aren't theoretical numbers either. There's some bizarre financial figures from a 4-agent LangChain loop that ran uncontrolled for 11 days and nobody noticed. The bill skyrocketed because nobody set an exit condition and nobody knew how to set it. Fair enough. And this is not just startups making this mistake. Uber also mentioned they rolled out Claude Code to roughly 5,000 engineers in December 2025 and burned through their entire 2026 AI budget by April this year. TechCrunch also reported that companies across the industry are blowing past their 2026 token budget by mid-year. Goldman Sachs projected that agentic tooling could push overall token demand 8 times current levels. Let that sink in for a moment. The times of replacing employees with AI just became a little bit more expensive. This is extremely important for you as the founder to weigh up the cost, look at every single workflow, get everything documented, and ensure that everything runs according to the budget and the projection that you set out for the business. Whether it's a one-person business or whether you need to go and hire VAs to assist in the process, that's a very, very important component to take into consideration. The mechanism is simple. Broad scope, no token cap, Recursive execution, each loop cycle compounds the cost of the one before it. And nobody on YouTube is showing you the bill. They show you the architecture perhaps with the diaphragm and cut to the results. The fix exists. Token budgets per cycle, hard exit conditions, caps per loop run, a hierarchical architecture that uses smaller, cheaper models for routine worker tasks can hit 97.7% of frontier accuracy at roughly 61% of the cost. But you have to build these guardrails intentionally. They don't come for free. That's what makes it important to look at when loops burn you. When do loops actually start to burn you? You see, this section matters most because these aren't just use cases. These are default behaviors, and if you don't design against them, it's going to design against you. First, the Ralph Wiggum loop. This is when your agent evaluates its own output and gives itself a passing grade every time. It's like making your own exam, you'll always pass. But Microsoft updated taxonomy of agentic AI failure modes, published June 2026, identifies excessive agency as one of the 7 new categories they added after a full year of red team engagements. An agent that judges its own work has no external constraint telling it the work isn't done. Second, goal drift. Your agent starts solving one problem and quietly shifts to a different one mid-loop without telling you. This has been formalized in 2026 research with actual measurable metrics. GD actions for when the agent actively pursues the wrong goal, and GD inaction for when it passively abandons the right one. Under value conflict, agents drift towards goals aligned with their trained preferences, not your instructions. For example, you told it to optimize for cost, but it optimizes for completeness. Neither of you noticed that. Then looking at the feedback loop poisoning. The agent outputs feedback into its inputs across cycles, and errors compound. Microsoft flagged this explicitly in their taxonomy. Each cycle amplifies the drift from the previous one. By cycle 10, the agent is confidently solving a problem you never asked it to solve. One industry analysis summed it up perfectly. Agentic AI systems don't fall suddenly, they drift over time. That's the danger. There's no crash, no error message, just slow, confident slide away from what you actually wanted. And that is crucially important, especially for security. You see, this part nobody in the context space is talking about, partly because they don't know how to set that up successfully, and I get why. Most of them haven't run loops against real systems with real credentials. But I have, and this section is going to make some of you a bit uncomfortable. An unintended loop is an unintended set of permissions running against your live systems. Every cycle, the agent can access whatever you gave it access to on day one. And most builders never revisit those permissions. You see, the numbers are stark. A peer-reviewed study audited 17,022 agent skills from a public marketplace. They found 520 of them with leaked credentials, with 1,708 distinct leakage patterns across 10 categories. The majority of those leaks came from something as simple as a debug, logging, console logs, and print statements left in production code, accounting for 73.5% of all credential exposures, and over 3/4 of those leaks required analyzing both code and natural language together to even detect. You see, your standard code scanner wouldn't catch them. Meanwhile, according to Google's Git Guardian's annual report, 28.6 million new secrets were exposed in public GitHub commits in 2025 alone, up to 34% year over year. Now, put a loop on top of that. Every cycle is another opportunity for a leaked credential to be accessed, used, or escalated. This is what the mechanism chain looks like. Broad permissions on day one. No permission review after deployment. Recursive loop execution. And each cycle inherits the full credential scope of the one before it. That's not a theoretical attack surface. That's what's running right now on thousands of machines. The data is clear. Organizations enforcing least privilege access for the AI agency is 17% security incident rate. Organizations that don't, NIST launched a formal AI agent standard initiative in February 2026 because of the gap between the current practice and the minimum safety is that wide. Something could be executing with your credentials at this very moment. And do you know exactly what it has access to or even how to stop it? And here's the flip side to this, because it isn't just about what goes wrong. Builders who get security right, who lock down permissions from day one, who audit agent access the way they audit a contractor's key card, those are builders shipping with confidence while everyone else is shipping with hope. Without even knowing it, that is the difference between an agent you trust and an agent you tolerate. Now, we talked a lot about what the research showed, but let's look at the compensation depth. You see, this concept was coined by Adi Osmani, an engineering leader at Google, earlier this year, and it's the best name I've heard for a problem every builder with AI is going to face, sooner or later. Here's the asymmetry. AI generates code at 100 to 200 lines per minute. A human developer writes 20 to 40 lines per minute. That's 5 to 7 times speed gap. Your loop wrote 500 lines at 3 a.m. It works, nobody knows why, and the day you need to debug that system, every minute you save writing it gets paid back with interest. According to Osmani's research, developers using AI-first works scored 10% lower on the code compensation assessments. They are shipping faster, but understanding less of what they ship. Pull requests per developer are up 20% with AI assistance, but incidents per pull request are up 23%. You are producing more and breaking more at the same time. Forrester predicts 75% of tech decision makers will face moderate to severe technical debt by the end of this year, with AI-generated code as a primary driver, and when compensation debt compounds, unmanaged AI code drives maintenance costs to 4 times traditional levels by year 2. Let that sink in. YouTube celebrates the speed, but nobody mentions the maintenance invoice. Think of it like hiring a contractor who builds twice as fast as anyone else but refuses to leave documentation, doesn't label the writing, and works exclusively at night. The house goes up quick, but the first time something breaks inside of the walls, you're tearing out drywall to figure out what's connected to what, and come up with some surprises about what you discover. Everything I've covered so far, the cost, the structures, the failure patterns, the security audit, the compensation depth, I've built production systems around all of that. With actual tool templates, the security configurations, the permission lockdown workflows, and that's all for you inside of the AI Founders Vault. I'm talking about the exact settings I use in my production agents, the 5-layer permission audit checklist I built after watching an agent escalate its own access, the token budget configuration that would have prevented thousands in API costs. Link is down in the description. Now knowing what you know, this is the question you should be asking yourself. Do I need this? That's the honest question. According to Gartner, there was a 1,445% surge in multi-agent system inquiries from the first quarter of 2024 to the second quarter of 2025. Everyone wants to build one, but Gartner also predict more than 40% of agentic AI projects will be cancelled by the end of 2027. The hype to reality gap is enormous. And this is why most solo builders do not need a loop. And don't see it as a failure. That's truly a engineering judgment based on this research. Think of it like this. Here's a 4-condition test I use before I build any form of loop within my infrastructure. 1, the task has natural checkpoints. You can verify progress at each stage, not just at the end. 2, failure is recoverable. If the loop goes wrong at step 7, you can roll it back without losing everything. 3, you can define done clearly, not make it better or keep improving. A specific measurable condition the AI agent can evaluate. 4, the cost of looping is less than the cost of doing it manually. If a well-written prompt and 15 minutes of your time gets the same result, you don't need a loop. You need a better way of communicating with the AI. If you can't pass all 4, don't build the loop. Save your tokens, save your debugging time, and save yourself from a system that runs confidently in the wrong direction while you sleep. Think of it as maker versus checker. This is the single most important pattern in this entire video, and almost nobody is demonstrating it. One agent grading its own work and making its own exam, we covered that. The fix is separation. One agent builds a completely separate agent with different instructions, reviews. The maker process. The checker verifies. They never share context about what the right answer should be. This is documented across multiple production orchestration frameworks, including Microsoft's taxonomy as a core pattern for reliable agent systems. Google's agent-to-agent protocol, released in April 2025, enables exactly this kind of operability between independent agents. The execution guard pattern, where a separate agent sits between the decision and any irreversible action, is gaining traction as the minimal viable safety layer for production loops. The cost doubles. I know, you're running 2 agents instead of 1, but think about what you're actually paying for. You're paying for the ability to trust the output. The maker-checker overhead is negligible compared to the cost of an undetected failure that compounds across 50 loop cycles. One bad output that passes self-review and feeds into the next cycle isn't a single mistake. It's a cascade. This is the pattern that separates loops that work from loops that lie to you. And here's the thing that nobody wants to say out loud because it doesn't make for a good thumbnail. The most experienced non-technical founders that I know use loops for at least 20% of their work. The other 80%, a well-written prompt, a clear objective, and a human in the loop. Not because loops don't work. They're phenomenal if done right. But most tasks don't necessarily need them. The real power move isn't building the most complex autonomous system that you can imagine. It's knowing exactly when to let the machine run and when to keep your hands on the wheel. So if you want the builder's perspective on AI, not just the hype cycle, subscribe. I ship these systems and I tell you what actually happens. Drop a comment down below, and if you're running loops right now, what broke first? I want to hear the real stories, not the demo reel. And if you want to go deeper, the full system is inside of the AI Founders Vault. The loop templates, the security configs, and the cost tracking infrastructure I use to audit every single agent run. The permission lockdown workflow that took me a massive amount of production incidences to get right. We're building the future together. Inside of the community, there's a large amount of non-technical founders. We are building the future together inside of the community. You are invited. Accept your invitation by clicking the link down below. See you in the next one.